Hi everyone, in today's video we will be talking about TinyUSB with Raspberry Pi Pico and also implementing a simple serial echo device with them. Let's learn more about it. So what is TinyUSB? It's an open source USB stack rated in C and supported by Adafruit. It's a lightweight, portable, tailored made for embedded devices like STM32, ESP32, Pico, etc. It has support for various device classes like UDC for serial communication, MSC for mass storage, HID, MID, etc. And why are we pairing it with Pico? Well, it's a dual-core ARM Cortex M0 Plus processor, a good amount of SRAM and 2 MB of onboard flash memory. But the real kicker is that it has a built-in USB device controller. Addition to that, TinyUSB core is natively supported by Pico SDK. This means we can make our Pico act as a USB serial port, mass storage device, keyboard, mouse, or even a composite device, doing multiple things at once. Plus, it's super affordable and has a great open source support. Now let's peek under the hood at TinyUSB architecture. At the bottom we have the MCU port, which includes the host control driver, the device control driver, and directly interacts with the USB hardware. Above that sits the OS abstraction layer, which makes TinyUSB portable across various systems and RTOS environments. Next, we reach the TinyUSB core, which provides host and device stacks, including USB-H and USB-D drivers and class APIs like TUH and TUD4, features such as CDC, MSC, and HID. And finally, at the top, there is the application layer where your firmware logic lives and interacts with the TinyUSB API. Now, how TinyUSB integrates with the Pico SDK. So there are some basic requirements. First, we will have a configuration header tsusbconfig.h and we will define a USB descriptor in a file descriptor. This descriptor has device descriptor, configuration descriptor, interface descriptor, and endpoint descriptor. Next, we will need to include the TinyUSB core and class header TUSB header in our project. In our main loop, we will initialize the TinyUSB stack by calling TinyUSB init and then continuously pull for the USB event using the TUD task. Next, we will link the TinyUSB library to our CMake file list. As you can see on the right hand side, there is a project structure, how we will be maintaining. There is a cmakefile.txt where we'll include all the library and dependency. There is this main.c file where our application firmware will reside, and there is this TUSB config h and USB descriptor.c file. Now let's build something. We are going to create a CDC or a serial echo device. What that means is we will be able to send some text from our computer to the Pico over a virtual serial port, and the Pico will echo that text right back to us. First up, our TinyUSB configure header file. We need to enable the device mode using the config TUD enable flag, enable the CDC device mode using the config TUD CDC flag, and configure our buffer sizes. We also need to define the TUD CDC endpoint buffer size that are same as TX and RX buffer values. We need to also set the maximum packet size for the endpoint. Then we need to define the root hub mode and which root hub to use. In our case, for Raspberry Pi Pico is 0. Next, in USB descriptor, we will see our USB descriptor. This is where we'll define the things like device descriptor, configuration descriptor, interface descriptor, and endpoint descriptor. This tells the host descriptor what our device is and what it can do. Next, in our main function, we will initialize the board and the USB stack, and then we will have our infinite loop from where we will call TUD task over and over to handle USB events. Next, we will define a callback function TUD RX callback that gets involved whenever the host sends data to our CDC interface. Inside this function, we will read the data from the host using the TUD CDC read API and write it back using the TUD CDC write, and then flush the data with the TUD CDC write flush. Finally, in our CMake list file, we will initialize the Pico SDK and our source file. We will also disable UART and enable USB configuration, and then make sure to link the necessary libraries like Pico standard lib for standard APIs, TinyUSB device for TinyUSB device stack APIs, and TinyUSB board for RPi based USB definition. Then we'll define the program name and the version. Then we'll finally define the output binary name. As you can see here on the left hand side, I have opened up VS Code where I have installed this Raspberry Pi Pico extension. What it does is it will install the Pico SDK and it will help us in implementing our project. This is our source file, that is where the main function resides. This is our callback function that we have implemented, and this is the CMake file where we add all the dependency libraries, all the source code, and we have defined this tsbconfig.h and the USB descriptor.c. These all extra make files is generated by Pico SDK itself, so we don't have to bother about that. Next, for compiling that project, we need to click on the Raspberry Pi Pico icon and we need to click on the project compile project button. As you can see below, the compilation is done. Then to run the project, what we have to do is we can either copy the generated .uf2 file from here to the microcontroller, or we can just click on the run project. Before doing that, we have to put Raspberry Pi Pico in USB mode. Keep holding USB boot button and plug it in. The device should show up as a USB device. We will close it and we will click on the run project. It should flash the binary, and on the device manager we should see the device coming up. So yeah, we can see that we are seeing USB COM port. This is our Raspberry Pi Pico. So to communicate with this, we will use a terminal program, that is CoolTerm. So before connecting to the device, what I'll do is I'll change some of the options like the baud rate and the terminal mode. What we'll do is we will set the line mode. What it will do is it will send the data only when enter is pressed. So now let's connect. It is connected. Let's type something. Hello Pico. Yeah, we received some data. Hello Pico. So if we see the source code, what we can say is we write, after on receiving data from host, we read the data into a buffer. We write 5 characters, that is receive, colon and space. Then we write back the data that we have read onto the buffer. Then we flush the buffer. So let's type something more. As you can see, we are receiving the data. And there you have it. We have successfully implemented a CDC virtual COM port eco device on Raspberry Pi Pico using the TinyUSB. We have configured all the necessary USB descriptor, handle host to device communication with the callback, and verified it all with a terminal program. This is just the tip of iceberg of what you can do with TinyUSB and Raspberry Pi Pico. I hope this video has inspired you to start experimenting and building your own awesome USB devices. If you found this video helpful, be sure to hit that like button and subscribe for more content like this, and let me know in the comments what you are planning to build with your TinyUSB. Thanks for watching, and we will see you in the next one.